My name is Alex Dworjan. I'm an Ansible Solutions Specialist, and today I'm going to be walking through the process of migrating old Ansible playbooks from Ansible Engine 2.9 and older into the new processes leveraging execution environments.
So what are the specific things I need to focus on as I go through this migration process? So really I want to start off with, am I leveraging collections today? That's the big aspect that changed from Ansible 2.9 to 2.10 and newer. So I really want to make sure I'm leveraging them throughout my playbook processes. Depending on what collection I'm using, I may need to build my own execution environments. So if I'm outside what the Red Hat supported EE provides, I might need to create my own execution environment, which I will walk through. Localhost, if I'm using that to write files, isn't what it used to be. Obviously, since I'm running execution environments, which essentially are containers, that container doesn't exist past that job run, so I may need to have to modify and move files to a specific virtual machine after that playbook run is completed. So to get started, I really need to make an execution environment if I have my own custom collections or I'm using things outside of what Red Hat provides. So I'm going to walk through a very quick process of using Ansible Builder to create those execution environments. Once I've created them, I can leverage Ansible Navigator to see exactly what is in my execution environment, from Python libraries to system dependencies to the collections themselves. And then I'm also going to use Ansible Navigator to run my playbooks. So I can still use Ansible Playbook, but Ansible Navigator is the way to run execution environments and my existing playbooks together. So should I be using collections? Absolutely yes. It is a best practice to leverage what we call the fully qualified collection name. Is it technically required? No. Ansible will try to do that resolution on the back end, but it is a best practice to ensure I'm getting the exact module that I want to be leveraging. So I can use collections with 2.9.10 and newer, so I can already start in this process if I'm leveraging 2.9. And again, this will ensure I'm using the collection when I'm running this module. This ensures that if down the line someone has the exact same module name between different collections, I don't have to worry about which collection Ansible will pick. So I generally like to start with that collection index, which I'll show here in a minute, which really lists almost every module that exists in Ansible. I'll do a nice Control F, do a find, look for my specific module, and make sure I have that collection in my larger list. If you already have a collections requirements.yaml file in your repository, great. Copy that, use that to make sure it's built into my existing EE, and then I can leverage VS Code and the Ansible extension to leverage that EE and some autocomplete capabilities to build out my playbooks. From the localhost side of things, as I said, it's not what it used to be. So localhost now is the container, which means if I expect files to live past that, I need to do some modifications. So I either need to copy that file to somewhere else, or there is the capability to mount specific folders with read-write capability. So I could leverage that as well. Most commonly, I do see delegating to a specific report host or something like that, which gives me that ability to write that file afterwards. If I'm doing API calls with localhost, that has not changed. I can still continue to leverage that, but just know that as far as the actual changing of file existence, I do need to write that to somewhere else. So let's dive into how this can look both from the building side as well as actually leveraging Ansible playbooks. So first I want to start with that module index. So this is a module index, which I'll include in the description below. This really has almost every module that exists in Ansible. It doesn't have some of the supported ones just based on naming conventions, but I can look for the EC2 instance module and figure out that it's part of the Amazon.aws collection. So a very easy, quick way to find exactly what collections modules live in. And if I want, I can just look at the different collections themselves and find kind of the most common collections and have a very easy way. Generally, based on individual playbooks, I know that I'm working with Cisco iOS or I'm working with Cisco ACI, so I should probably include that particular collection in my module. And it's nice that collections are designed at really technology levels. So I can also check Automation Hub to see the Red Hat supported ones. So this gives me the list of 140 different collections that exist that I can leverage also through my process, whether that's for Automation Controller itself or for the certified content like Cisco iOS. So let's jump into the build process. So I'm right now on a virtual machine that has Ansible Builder already installed, which is obviously necessary from a command line side to actually have this working. So I'm running on version 1.2.0. The key aspect is I basically need to define what my execution environment looks like. So I have a base image that I'm building off of, which is a min rel 8 image, which essentially has Ansible core and the necessary Python dependencies for Ansible core to run. That's it. I have a bit builder image that helps with some of the Python aspects in the background. Then I have an Ansible config, which tells Ansible where to pull my collections from. In this case, I'm using my private automation hub, but you can have this set to pull from public Galaxy, private automation hub, public automation hub, however you want it to set up. And then I define what my specific requirements are. So whether I've got collections, Python dependencies, or system dependencies, that's all maintained here. And I can even add additional prepend and append steps, just like any other container or Docker file. All of that's really part of this process. So I've got mine where I add in some specific Git settings on top of what I do just with building this image. So first I'll dive into that Ansible config. And as you can see, this is just the list of servers that I have available for Ansible Builder when it pulls in collections. So I'm pulling from my private automation hub with a specific token that has authentication to pull those specific collections. I don't have it set up to pull from public automation hub or from public Galaxy because I don't want that capability. For the requirements.yaml, which are my collections, I have 3 collections placed in here. So Cisco, iOS, Arista EOS, and Cisco ASA. And if you've noticed for the Cisco ASA, I have it specifically locked to a version. So I know anytime I build this execution environment, I will use version 3.1.0. For the other 2 collections, I will pull whatever the latest version of that collection is from Private Automation Hub. So I can also define specific Python requirements. So in this case, I've got 3 additional Python requirements. For me, I've got some things with Cisco that I like to do in terms of pulling and structuring data. And also I have SCP so I can make sure that when I write to new firmware, I have that capability as well. From the system side of things, I like to do a lot of extra Git capability within my execution environment. So I'm actually writing backups back to Git. So I added the Git system dependency in. So that's really all I need. So then when I actually want to run Ansible Builder, it's as simple as Ansible Builder, build, and then tag it to some sort of image. So this could be basically your private automation hub name, and then whatever I want to call the image. So this could be network EE, and then maybe tag latest or tag 1.0, and then it goes through that build process. Ansible Builder is smart enough as it goes through the build process, it will also take in the different requirements that are listed in the collections. So I leverage the Azure collection quite a bit. And if you notice, this requirements.txt in the Azure collection has 52 lines worth of Python requirements that they keep track of. I don't include this in my requirements.txt because it's pulled directly from this collection during the build process. So it significantly streamlines some of the back-end work that you need to do. So once I complete this build, I can push this to Quay, I can push this to Private Automation Hub or really any container registry, and then it becomes available for me to use in Ansible Navigator. So Ansible Navigator is that utility to run my playbooks, check out what's kind of inside them. So I can go to this images section, see the execution environments that are available for me. This is an execution environment that I built 2 days ago. So I'm going to hit 1 to jump into that. And maybe I want to see those Python packages that are included in this execution environment. So I'd have to jump into Python virtual environments. I don't have to do pip freeze or pip list or anything like that. I can just jump into this text user interface and see all the different Python libraries that are installed and the exact versions. You'll see I have all those different Azure requirements that I talked about just a minute ago. And I have 260 total Python libraries that are in here. And I have significantly less. I think I have about 5 in my definition for my requirements.txt. So this greatly simplifies the process where it pulls directly from either a bind-up file in that collection or the requirements.txt to pull in both the system and Python dependencies. So all of this process is really automated, which allows me to rebuild this weekly, and I will never worry about will a Python dependency fail because I'm pulling it directly from the exact version that that collection requires. So again, it has significantly streamlined this process for me, but now I have an execution environment, Shadowman EE 9.2, ready to go. How do I leverage that? Well, I have VS Code here installed, in this case, as a code server running my browser. So I fortunately have the Ansible extension installed as well. So if I jump into the settings for that Ansible extension, there are a bunch of settings that help with fully qualified collection names and leveraging that execution environment. So I already have execution environments enabled with my specific EE, so I know I'm only going to get the collections that are available to me. And I also have Ansible syntax checking and linting set up, so I'll even get some of the best of breed rules as I go through this process. So I have an old playbook here, and actually you can see it's already giving me errors because I'm not using fully qualified collection names, which is part of the latest lint versions, but maybe I don't remember what collection yum is part of. Fortunately, I do know it's part of Ansible.built-in, but all I'm going to do is take this existing playbook, hit backspace twice, and retype that M, and it's going to give me that fully qualified collection. I can just hit tab, and now I've modified it. And because of the syntax highlighting, I can see that these are the correct parameters that still fall under yum. So if for some reason, maybe this was names in a previous version, I'll notice that it doesn't have that correct highlighting, so I'll need to change those particular parameters as well. And I can highlight over, see the specific requirements for these modules. I can see that none of these are deprecated, and whether it's a string or a Boolean, it gives me all that capability. So the same thing for set fact, hit backspace twice, hit T, it'll give me the Ansible.built-in set fact. I can just hit tab and I'm off and running. So again, streamlines a lot of that process where I don't have to keep track exactly which collection these pieces are a part of, but I can go through and modify my entire playbook to very easily have the exact collections that are part of this, whether it's, again, Cisco iOS or whether it's, the built-in capabilities. And as I talked about, I don't have the AWS collection. So if I try to do AWS EC2, so I'll just do EC2 instance like I talked about before, it's giving me the built-in one, not the Amazon.aws collection, because I don't have that installed in my execution environment. So again, gives that kind of extra clarity as I'm building out playbooks, whether these things are actually available to me. So from the networking side for localhost, when I do backups, it's actually pulling them to localhost. And in this case, it should be writing it to /temp/home/network. So I can do Ansible Navigator to run this playbook. And because maybe I don't even want to run Ansible Navigator from the command line, again, I have this extension set up to do Ansible Navigator run directly through the web IDE. So it's actually going to run this playbook, and it will give me, in theory, a backup saved to /temp/home/network. So it will go through that process, and I can see it's already doing the backup. It's, sanitizing some things so I don't have enable, and I can see that it's completed. But if I actually try to go to that particular folder, for some reason, I won't find that. So I'm going to try to go to /temp/home/network, and it doesn't exist. Why? Because as part of the backup module, it's backing up to the container. As soon as that job run finished, that container was destroyed, and none of that information was copied over to a local host because I don't have that mounted to anywhere. Easiest modification is at the end of the playbook, add in, copy it to a managed host, which in this case, I'm just copying it to the current server I'm running on. So if I run this now, it's going to do the exact same backup process, but all it's going to do is at the end, it will then copy those files to that specific folder that I want them to. So it's a very easy way to copy things to a report server, any sort of storage volume that you have, or back it up to something like Git so I don't have to worry. So I can see now it's doing the actual copy process. So I will notice that now if I go into and try to go to that folder, it now exists. So that backup was completed. I can see my one router in this case was successfully backed up. It's going to be a very easy way to build execution environments, modify playbooks to use fully qualified collection names, and make some changes to playbooks to copy things to that final server so it doesn't end up just on the EE, but now it ends up on a server that I have access to get that particular backup. So where can I go from here? So I would definitely recommend starting with that Ansible module index as well as Automation Hub to see what supported collections there are. There's also the 1.2 to 2 migration guide that exists that goes through not just the playbook side, but also goes through actually upgrading the platform itself. There's some considerations to walk through, which include, are you leveraging collections? Are you using local hosts in different areas? That you should definitely consider as you go through this. But for this specific case, this is really focused on the playbook and execution environment side of things, which I will admit seemed a lot more daunting before I got started. But leveraging this VS Code extension and Ansible Builder to easily streamline these processes, it's helped significantly. Now, every time I run Ansible Builder, I actually have it running at 3 a.m. on Saturday because I fully automated that process. So I'm always ready to go with that next greatest image, with any CVEs patched, the latest collections, the latest Python libraries that I know will work because I'm pulling it directly from the collection maintainers. So it has significantly streamlined that process. So thank you for taking the time to learn a little bit more about how I can change playbooks that existed with 2.9 to leverage the new capabilities of execution environments. Thank you.